So this would be the week 3 summary for Physics 112 with David Weaver over at CGCC. When we got to class Tuesday, we saw different frequency ranges and some questions up here pertaining to different types of frequencies on the board. And our group had radio frequency, and we all got together and we did some research and figured out these 7 answers to the questions. And here they are. You can see the frequency range for radio frequency is 3 kilohertz to 300 gigahertz wavelength, 1 millimeter to 100 kilometers. 1 millimeter is about the size of a pinhead, and 100 kilometers about the distance between class and Anthem, which is about 62 miles. It has a natural source of electromagnetic radiation, so the sun and lighting. Man-made sources would be like MRIs. What is the charge that is accelerating, and oscillations between the electrons in a conductor. And then some cool applications would be some mobile radio communication, broadcasting, radar, and other different types of navigation systems. And then we got into light, and we went on to nbc.asu.edu, and we did some of these primary colors of light and subtractive colors of light. And you can see right here, we completed that in class. The 3 primary colors of light would be red, green, and blue, and then subtractive colors would be cyan, magenta, and yellow. And then we also learned that whether something is transparent or opaque is dependent on its wavelength. And then you can see here, this was Thursday's class, we started getting into different lights, and we were doing reflective surfaces and seeing how the angles that they would bounce off of for flat, curved, and what kind of a reverse curve would reflect off of there, and what degrees that would come out as. You can see right here we opened it up, and on this one you can see right here we have a slit right here. It blocks it and only lets one light ray go through. Right here, that's removed, so you can see all the different rays going through. And this is on the flat surface, so they're all just pretty even, kind of fans out. And then we went into kind of a lens, and you can see right here on this certain angle right here, it breaks it down. You can see a nice little rainbow right there. We learned about the laws of refraction. Snell's law, n1 sine theta 1 equals n2 sine theta 2. And the higher the index of refraction, the slower the light goes through. And that's on an average, that is true. And you can see right here, we did some graphing with the different degrees. You can see our input and the output of what it would come out. So we had 0, 0, 10, 6, 20 degrees, 14. And that's just the degree that it would refract off of. And then we came into some polarization, and you can see right here the poles are lined up 0 degrees and 0 degrees, and you can see the different colors of this little pamphlet through the background right there. And then if you turn it 90 degrees, so you can see right here 0 or 90 degrees, it completely blocks it off because the poles are not allowing any light through. So that was kind of cool to see. And then this was really cool. We looked through this little thing right here, this diffraction lens, and this was air actually lit up, kind of a plasma of air, and you can see this really cool rainbow. And this is actually just a picture looking through that at the lit up air particles. And then some Arduino. So this one, my video didn't really work on this, so I can't really show that. But right here, we got that light sensor. So once you turn it on, I have a video of that. Hopefully it works. You could cover that up, and it would change the frequency. And then this is the keyboard one. So each one has a different resistor on there, and it would allow different frequencies through. So in a sense, it's kind of like a keyboard. You can change different pitches. Let me see if I can pull that up. And here's this. This is the first one. The video is really bad, but you see, you can when you cover up the light sensor, it'll change the different frequencies. And then here's the video with the different push buttons. You can hear the different frequencies. Kept thinking that if I could put some more buttons in there, and change the sound, I could try and come up with a song, but that never really happened. And that is what we did on week 3 in physics.